Welcome back, dear students. I hope the last session has been helpful for you all. Now I'm back with the new topic, that is equation of accelerated motion. Now the equation of accelerated motion. Consider the motion of an object along a straight line with constant acceleration. Then the acceleration of the object is shown on the screen. Let u be the velocity at the time t is equal to 0 and v with the velocity at the time t, let h be the displacement covered by the body during time t. Therefore, the uniform acceleration is shown on the screen. Acceleration a is equal to v minus u by t, or acceleration into time is equal to v minus u, or u plus at is equal to v. Consider this equation as the first equation. Since the acceleration of the body is constant, average velocity is equal to v plus u by 2. But we know average velocity is equal to displacement by time taken. So v plus u by 2 is equal to s by t. Consider it as a equation 2. We get the following equation by solving the equation 1 and 2. U plus at is equal to v. So we'll get what? U plus at plus u by 2 is equal to s by t. After that, by concluding everything, we'll get ut plus half at square is equal to t. Consider it as a third equation. By solving the 1 and 3 equation, we get the following equation, that is, as you can see on the screen, by solving the first and third equation, we'll get v square minus u square is equal to 2as. We'll have three equation over here. That is, first is u plus at is equal to v, ut plus half at square, and the v square minus u square is equal to 2as. If the speed of an object increases, the direction of velocity and acceleration are the same. If the speed of the object decreases, the direction of velocity and the acceleration are in opposite direction. In such a case, a certain instant speed becomes 0. If there exists an acceleration of a body at a point where its speed becomes 0 for an instant, then the body returns in the direction of acceleration and moves continuously, like in the case of a stone thrown vertically up into the air. Using equation of motion. Next topic is how to use equation of motion. You can see these are the three equations of motion. The following parts are to be remembered while using the equation of motion. First, choose origin on a straight line. The quantities directed due right are taken as positive and due left are taken as negative. Second is expressing the displacement with proper sign is important. Displacement is positive while measured along the positive direction and is negative while measured along negative direction. Now let's perform an activity to understand the acceleration and velocity of an object. Alright, so we'll have to tick on the aims, and our aim of this activity is to find the acceleration and velocity of an object moving on an inclined track. What is the required material needed for this activity? The material used in the lab activities are glass marble, plastic pipe, digital stopwatch, books, and steel plate. Now, what is the procedure to perform this activity? Take two books, place them on a table. Take a long plastic tube. Cut it half along the length of the tube. Mark the reading in centimeter along the length of the tube. Now place one end of the tube on the books and the other end on the table to make an inclined track. Now take a steel plate. Place it at the bottom of the track. Take a marble having enough size to travel in the track freely. Now release the marble freely from a certain distance, 20 cm, and start the digital watch simultaneously. Stop the digital watch when sound is produced. Repeat the same experiment for the same distance 2 to 3 times. Note the value of times in the observation table. Find the average time and 2s by t square for every trial. Draw the distance versus time graph for all values. Now what we have observed in this activity, we observed that for every trial the average time and the acceleration remains the same. What are inference? Let's see what we have learned. With no change in the inclination, initial velocity and the distance traveled, there will be no change in the time taken for the travel and the acceleration during the travel. Now we have some equation to solve over here. Question number 3, this starting from a stationary position, Shravan pedals his bicycle to attain a velocity of 3 meters per second in 60 seconds. Then he applies brakes such that the velocity of the bicycle comes down to 4 meters per second in the next 4 seconds. Calculate the acceleration of the bicycle in both the cases. Now the next question is, a car travels from the rest with a constant acceleration a for t seconds. What is the speed of the car for its journey if the car moves along a straight road? Now the next question is, a particle moving with constant acceleration of 3 meters per second square due west has an initial velocity of 9 meters per second due east. So find the distance covered in the 5th second of its motion. So I hope you all gone through all the questions given on the screen. After reading the question, understanding the question, we have to write the given point. And again we can see that the solution, you can see solution given over here. Clearly notice the solution. This is the solution for question number 3. Now let's see the question number 4 solution. You can see that this is the solution for question number 4. Clearly observe. Now let's see for the last question solution, that is question number 5. You can see that. I hope you all are getting it. This is the solution for the question number 5. Clearly notice it. Try to write down on your notebook and try to solve the equation. I hope the topic is clear for everyone. We will back with the new topic with the new energy. Thank you so much.